The third speaker for this session is Michael Fisher. He's a professor of computer science and Royal Academy of Engineers Chair in Emerging Technologies at the University of Manchester. His research concerns autonomous systems, particularly verification, software engineering, self-awareness, and trustworthiness, with applications across robotics and autonomous vehicles. Increasingly, his work encompasses not just safety, but broader ethical issues such as sustainability and responsibility across these technologies. Michael Fisher works in several standards institutions and is also currently on a secondment to the UK Government Department for Science, Innovation and Technology. Michael, the floor is yours.
Okay, thank you. Can you hear me?
Yes.
Excellent. Okay, thank you. Yes, I'm going to give a talk about autonomous systems, the ethics and responsibility related to autonomous systems. So not just ethics and responsibility of ourselves in producing these systems, but also the responsibility within those systems once they can make their own decisions. So there's not going to be any videos in this, but a few pictures, and I'll try and give some general ideas. So just a few slides on each of these different things. What's an autonomous system? Why we care about building these things? An issue about when we're designing these systems, it's our responsibility to make sure that they're as reliable as possible. As the previous speaker said, you want to be able to trust these systems. Then the third item, once these systems, let's call them robots, for example, can make their own decisions, we need to make sure that they will act ethically on their own, not just us being ethical in building these systems. And the final one, I want to mention something about sustainability. So I'm going to give 2 or 3 slides on each of these things, just to give you a flavor of what's going on. So what's an autonomous system? So autonomy is just, as it says there, the ability to a system to make its own decisions and to act on its own without human intervention. And this could be lots of different types of systems. I have pictures here of lots of different robotic systems, but it doesn't have to be a physical embodiment. It could be an AI system on the internet. But, you know, there are pictures there of robots either in the home or vehicles such as flying cars or Mars rovers or any of those different things, medical robots. All of these systems, in principle, can make their own decisions about what to do. And we're trying to give them more and more autonomy to achieve better and better results. So the question is not whether we can give them autonomy, it's whether we can give them autonomy but have reliable ways to do that, to make sure that the autonomy we give them is trustworthy. And as the previous speaker mentioned, we need to be able to trust these systems. If we've decided to give autonomy to our favorite robot and it makes choices on its own, then we need to be able to trust that it will make the choices that we would expect it to. We don't have control of this thing anymore. Okay, so autonomous systems are a whole range of these systems, and I'm not going to give videos, but we build various of these systems and program them and deploy them in lots of different areas. So there's an issue here about decision making. The key aspect of autonomy is making decisions independently. Who makes those decisions? In the very basic case, there's a human controlling your favorite system. So a remote controlled robot, for example, or a driverless car where the human is actually driving the car, those types of things. So human controlled systems, they may be inefficient, but at least we know who to blame when something goes wrong. Then there's a whole range of system controlled decisions, and they could be very simple, like automatic, where we've prescribed a series of actions, a series of activities that will be taken, and we just go through them in a list. So your automatic washing machine, for example, or anything like that just goes through a list of activities. Moving on to things like adaptive systems, where the system makes some decision, but actually most of the decisions are taken in interaction with their environment. So essentially you learn from the environment what decision to make. And a lot of the learning systems you see nowadays are adaptive in this form. And then things like fully autonomous systems, where these systems have their inbuilt decision-making processes and they make decisions independently of what's going on in the outside world. So they can watch what's going on, but make some decision about what the best thing to do is. So there's a whole range of different autonomous systems. We're particularly interested in the bottom one, where There's no humans anywhere near these or not controlling these systems, and the systems have to make decisions on their own, sometimes quite critical decisions about what to do. So different forms of autonomous systems, and we're going to build these systems and we're going to give them the ability to make their own decisions and take their own actions. So we have to be able to trust them. As the previous speaker said, you need to be able to trust what this system will do. You've just given it agency, if you like, delegated it, as the first speaker said. Now you have a system, whether it's an AI system or a robot, that will make a decision that may affect you, and you have to be able to trust that this thing will do the right thing. And we need to, we can't guarantee trust, but we can at least make systems trustworthy. So trust is very subjective. What you trust and what I trust are very different, and the reasons we have for trusting things are very different. So as the previous speaker said, a lot of it is psychological studies about what generates trust in different people. But more generally, we can at least make the systems trustworthy. And in this sense, it means trying to give the systems properties that are more likely to make you trust them. And I've given 2 example robots here, all the way from a seemingly harmless seal all the way up to something that seemingly seems dangerous. So we need to be able to trust that these systems are doing what we expect or doing what we want. So when we start building these systems, we want to make them as trustworthy as possible. And let me say something about how we want to make sure that the systems are trustworthy and what this involves. So trustworthiness, as I mentioned, trust is very subjective. You and I will trust things for different reasons. Trustworthiness is slightly less subjective and more about the system. So in traditional systems, trustworthiness is essentially reliability. So the picture at the top there is a toaster. You believe your toaster is trustworthy if it cooks the bread to the right color. It burns it just the right amount that you expect. And so a lot of typical systems that we have at the moment that aren't autonomous, trustworthiness is almost the same as reliability. Once we move on to autonomous systems that can make their own decisions, it's not just a question of how reliable they are, it's whether you believe these systems are working for your benefit. And this thing called beneficiality. And a prime example is our favorite Terminator robot there. It's very reliable. So, from normal systems view, you should trust it, but you believe it's trying to do you harm. You believe it's going to make decisions that are against you, essentially. So understanding that trustworthiness comes in several flavors and includes both reliability and, if it's making its own decisions, some confidence that the decisions it will make are the right ones for you, then that's important too. So this beneficiality is really important when we get to autonomous systems, whether it's robots or AI that makes decisions that will affect you. And then the final thing I just mentioned at the bottom is appearance, as I think the previous speaker mentioned. If you have 2 robots, one looks cute and cuddly and the other one looks scary, you're more likely to trust the cute and cuddly one, probably. But we're not going to talk about appearance too much. So trustworthiness, we need to be able to not only show that our systems are reliable, and we should make sure our systems are reliable, but we should also be transparent in what these systems are doing and why they're doing it. So when we build systems, whether it's AI systems or robots, then having some way of exposing exactly what the system is doing is very important. And it's here that we need transparency in these systems. We actually need to expose the programming of the system, expose the way the system is built, and be able to work out exactly what the system is doing and ask it. It should be able to answer. If you ask it, why did you do that? Or what are you going to do next? The system should be able to answer truthfully. It shouldn't just say, oh, I don't know. It was some black box component it was some large language model told me to do it. That isn't good enough. It's got to have transparency. And without that transparency, you won't get the trustworthiness you need in these systems. So transparency is really important, and it's not impossible at all. We built these systems, we coded these systems. Making sure that it's transparent why decisions are made is really important, or what decisions are going to be made. So transparency is important for lots of different things, exposing what the system is doing, for explainability, but also for verification. If you want to do strong verification of these systems to actually, for example, prove that the system won't do a bad thing, then you need a transparent, not fully transparent, but transparent in the way it makes decisions. Once you have transparency, you can have more confidence, the user can have more confidence in these systems, and you can have assurance and regulatory approvals. Transparency is going to be very important to us. The way you build systems is very important. And going back to the original title of the talk, it's our responsibility to build these systems in a transparent way so that when we interact with people, people have more confidence in what's going on and can ask the systems, why are you doing that? And what was the reason you did that? And what was the reason you didn't do something else? That's very important. The other thing we have to do is to, especially when we have robots, but just in general with autonomous systems or any software system, things will go wrong. There's always something that will break. And software will fail in some places. Obviously, physical systems will break. We have to be aware that the things that we expect to happen might not happen at all. So we have to be explicit about the assumptions we make before these systems are deployed. Often when we look at systems or design systems, we make lots of assumptions about what the world will be like. Almost all of those are wrong, but we need to be explicit about those assumptions. We need to check when the software or the system is running to make sure that the world hasn't changed or something hasn't broken. And we need strong mechanisms in place to cope with the fact that everything will fail, something will go wrong. And so I think I've just given some text from a new standard that's come out, an IEEE standard on fail-safe design, where it's about trying to capture these fail-safe mechanisms, trying to make sure that not only do you have the fail-safe mechanisms, but they're actually reliable when they come into play. So think of your favorite robot. If something goes wrong with it, you need it to fail safely in a sensible way. Sensible might just be switching itself off, but if that's a flying car or something like that, or a driverless car that's going in the fast lane of your highway, then that's probably not a good way to do things. So lots of different fail-safe mechanisms that get you to a safe state, wherever it is. So it's our responsibility as designers and developers of these systems to make sure not only that they're transparent and that we can carry out verification and therefore lead to trustworthiness, but we recognize that they will fail at some point and have some plans in place for what to do when they fail. Our assumptions will always be wrong. Okay, so that was the first part. It's our responsibility to make sure these systems are as reliable as possible and can cope with failure. Then we've got to consider the issue that autonomous systems make decisions on their own. If they're allowed to make decisions on their own, at some point they have to make critical decisions and maybe even, I don't want to get into a philosophical argument, but ethical decisions. Decisions that when a human makes them will be considered ethical. So how can we make sure that the systems make the decisions we care about, make the decisions that they have in an ethical terms in the right way? There are lots of different decisions that these systems make, and this is just one sort of hierarchy of decisions from at the bottom. Reactions to what happens in the environment. For example, suddenly an obstacle appears in front of your vehicle, you have to make a reaction, you have to do something about that. Up to, let's think of driverless cars. So some obstacle suddenly appears, it has to react quickly and move out of the way, for example. But also it has to follow rules of some form. So there are various rules. If it's driverless car, there are rules of the road in whichever jurisdiction you're in, whichever country you're in, it has to follow various rules. And then when it gets to the top of principles, these are ethical principles where none of the rules apply. You don't know what to do, but you've got to do something, and you hit things like the trolley problem and all those sort of philosophical problems at the top here. But they're ethical decisions that the system has to make. And understanding when the system has to make these and making sure that the system makes them in the right way is an important thing in these types of autonomous systems. So capturing what's going on is very important. And again, transparency is going to be the key to all this, understanding the reasons for making decisions, understanding the way this system makes decisions and how it chooses, why it chooses one thing and not another is very important. We can, with enough transparency, we can not only do explainability, explain why decisions are made, but do some verification beforehand to verify the way that the system makes decisions is going to be the right one. And we know that the way it makes decisions prioritizes the ethical issues that we consider to be the most important ones. And once we're worrying about these things, that hierarchy, it's not so much the decisions that are made, it's why those decisions are made become important. So we're moving away from just what it is you do and when you do it, why did you make that decision? And if you think about humans that you trust, if something goes wrong, you would like to ask them, why did you make that decision? What was the reason you did that? And if they did it for the right reasons, you believe to be the right reasons, then the fact that something went wrong is less important. They've done it for the right reasons. You trust them to be doing the right things. So understanding why decisions are made is really important for, particularly for these critical decisions, ethical decisions, when, for example, you have a robot in the home or a robot that's in control of some vehicle that has people inside. It has to make some critical decisions and it can't stop and wait for the human to tell it what to do. It has to be clear about what's going on. So you need to understand the way it makes decisions before you even deploy this thing and do some analysis of what's going on. And again, it's going to be transparency of those things. Okay, so that was just the second one to highlight some issues that we have to be worried about when these systems are autonomous. They're going to have some decisions they have to make that are quite critical once we allow them to do more and more things. Then the last item I want to mention is sustainability. I think one of the previous speakers mentioned about sustainability, but I've got several different dimensions of sustainability. The most obvious one is environmental sustainability. If you think of robots, for example, we've seen lots of pictures of robots so far. Clearly, there's an environmental sustainability issue here in actually building those robots, mining the materials, producing the robots, providing the energy or the batteries for the robots. Then there's the issue of wherever the robot is. It might be doing something unpleasant to the environment. There might be some emissions from the robot, any of those different aspects. And when it comes to the end of its life, how do we repurpose it or decommission it? How do we make sure that, as it says in the text there, that the robot, these types of systems don't become part of the problem to do with environmental sustainability? So understanding that is very important for physical systems, but I want to highlight the issues with software, with digital systems in general. Software, especially as we're moving to more and more data-driven AI, might be a much worse problem than the hardware of robots, for example. You all know that data-driven AI requires or is built on this mantra that the more data you have, the better solutions you'll have, which is not necessarily true. But more and more data seems to be collected, more and more data is used for training these systems, and you need bigger data centers, you need more communications to cloud servers, you need lots of different things like that. So there are environmental sustainability issues to do with materials, obviously building new data centers, new communications links, etc. A lot of the materials are not in the place where the data center is being built. So, maybe there's somewhere in Africa where there's mines where we're digging up the ground to find these materials. There's obviously the issue with electricity and how much electricity is used for powering those data centers for the large language model training, for example, those types of things, but also things like water, cooling those data centers, making sure that if your data center is very, very big and it's heating the environment, that it's not heating the environment in the wrong places. So all these issues are really important and difficult, and understanding that we have these technologies now that are not necessarily great for the environment and that we use them far too much is very important. A couple of slides left before I stop. I just wanted to mention this is a standard that we did in the UK to do with the ethical design and application of robots. But if you replace the word robot by any software system or any AI system, then those words in green are a lot of the things we need to consider when we're developing these systems. Sort of dehumanization of this software, anthropomorphism, all those different types of things. So there are lots of works on trying to provide standards and guidelines for ethical design and application of, well, in this case, robots, but software in general, autonomous systems in general, and this is one example of that. And then the last thing I want to say is again related to sustainability, and it's about the often unnecessary, well, sometimes unnecessary use of digital technology. We should always ask when we have a solution that is either software or a robot or any of these things, do we really need this? Was it really necessary? Is there a much simpler technology, or could a human do this in a much simpler way? why do we actually need this thing? So we should always ask that. There's far too much technology that's deployed without actually being of much use. But then we should also ask the people most affected by this technology. Often we have, for example, in things like smart cities, often technology is deployed without actually asking people about that technology, whether they actually want it. And so asking people who are most affected by this technology, whether they want it and do they understand what benefit, if there is any, it will have, is really important. So I just wanted to mention that last part as part of sustainability, more social sustainability, but yeah, those are the last issues. So I just want to give a run through some of the issues to do with building autonomous systems, to do with autonomous systems and how they make decisions on their own, and then sustainability aspects at the end. So I will stop there.